In the last video, we looked at lead acid batteries, and what we actually did was we created a very primitive homemade lead acid battery using a beaker filled with sulfuric acid and some strips of lead, and sure enough we were able to charge it, and we were able to also discharge it and use it to light a little light bulb for a few seconds to prove that it worked even if it wasn't a very good battery. In this video, what we're going to do is look at some real batteries like these ones over here. These are gel cells, which are a type of battery in the group of valve regulated lead acid batteries, and also known as sealed lead acid batteries. And they have the nice feature that, well, you can tip them over, even hold them upside down, and they don't leak acid. And that can be very important for things like mobility scooters or computer UPSs, even things like burglar alarms where you have the installer maybe standing on top of a ladder and you don't want them to have to worry about not spilling acid all over themselves and everything else in the alarm. And the way they make these cells is it's essentially the same chemistry as a liquid lead acid battery, but they add something to gel the liquid, and apparently in a lot of cases it's just adding something like silica dust to the liquid, although I'm sure various manufacturers have their own proprietary techniques. So that's how these batteries are set up and used. The unfortunate thing is, like all batteries, and lead acid batteries in particular and are no exception, they tend to wear out over time, and these batteries tend to have three fairly common failure mechanisms, and that's in fact the subject of this video, not the failure mechanisms, but whether we can reverse the process. So what are the failure mechanisms? Well, the one that you hear most about is sulfation. And sulfation occurs when you have one of these batteries and you use it and you fail to recharge it and you leave it in a discharged state for a significant period of time, weeks, months, whatever. And when you do that, the plates, which are covered in lead sulfate when it's discharged, begin to change the composition of that lead sulfate, and that lead sulfate crystallizes and forms a hard and non-conductive crystal. So it's like you have a hard insulating layer covering the plates, and the problem with that is it stops current flowing to or from the plates, and what that means is it's virtually impossible to charge them, and that renders the battery useless under normal conditions. The other thing happens in the case of batteries that are can be used fairly regularly or even a lot, is every time you charge and discharge them, a chemical process occurs on the surface of the plates. Namely, you have lead turning to lead sulfate, or lead oxide turning to lead sulfate, depending on the plate you're talking about, and the reverse process when you're charging the cell. Well, every time you do that, not all the changed material, the changed chemicals, gets properly deposited back on the plates, and some of it flakes down, and you sort of get a layer of sludge forming at the bottom of the battery. And things like lead and lead oxide are somewhat conductive, even if they're not greatly conductive, particularly if they're in flakes of sort of sand or dust-like form. But it's enough to cause a low-level discharge between the various plates in the battery, and well, that sort of renders the battery not so great after time. The other thing you have is drying out. And if you sort of imagine this battery is in a UPS, the UPS is in a box of some kind, a plastic box, to protect the electronics. That electronics gets warm because it's continually having some current go through it. Well, that keeps the battery nice and warm. Maybe nice is not a good term. It's also typically right next to a computer, which also tends to keep it warm. And you're typically continually putting a small charging current on the terminals. That adds to the warmth of the battery. Well, over time they tend to dry out, even if they are supposedly sealed, because, well, what they have is these little caps which are somewhat sealed, but they still are loose enough to allow vapor to get out, because you don't want the battery to explode if some vapor is given off because of the heat. So they tend to lose water vapor that way. The other thing that may happen is in a lot of cases the chargers, at least in old UPSs or burglar alarms, were fairly primitive and they sort of pass a limited current through the battery at all times. Well, as the battery gets fully charged, that will begin to lead to things like hydrogen and oxygen being given off by the battery, even though various changes to the chemistry have been developed over the years to minimize that. It still happens. The bottom line is, after a number of years of use, these things dry out. And of course, if there is no electrolyte, it's all dry, they don't work very well. So those are the three core mechanisms. The one other thing I should point out, and that's in the case of sulfation, and by the way, this battery over here is really sulfate, and that's why I hacked it apart. And what you can see in here is, well, the telltale signs of a lot of white, that is the lead sulfate. Well, that lead sulfate not only becomes non-conductive, it also takes up more volume than the original plate material did. And in a really badly sulfated battery, what you can actually see on the edges is a fair amount of bulging. And when you have bulging like that, it not only causes the boundaries between the various cells in the battery to sometimes break and cause current leakage, it also causes the insulation between the various plates in the battery itself to fail and cause discharge that way. So you can get severe damage from leaving a battery uncharged from the whole sulfation thing. The bottom line is, no matter what you do to the battery, whether you treat it nicely or not, over time it doesn't work that well. If you're lucky and the battery isn't too badly damaged, and usually the case is a slightly sulfated battery that maybe has only been discharged for a few weeks or maybe even months or so, can you fix it? And the answer is yes, or I wouldn't be doing this video. Well, how do we rejuvenate a battery like that? Well, I did some experimenting and researching, and it turns out that if you take a battery like this that is in fairly good condition, meaning it hasn't spent 3 or 4 years just degrading and failing and sulfating to the point of no return, well, what you can do is you can apply a higher than normal charging voltage to it and hopefully fix it. Now, what I did find was you do need to have the battery in good enough condition that there is at least a low enough resistance between these terminals to accept some current. And when I say low enough, I mean something probably in the range of tens of ohms or hundreds of ohms. I would suspect that by the time you get into the kilo ohm range, it's no good anymore. And this is where I found that battery tester meter that FNIRSI sent me a while back so useful, because it's fairly easy to test these batteries and see what their initial state is. And there's really no other way of finding out, particularly if they're completely discharged. Well, so taking a couple of batteries that had, I think it was like 400 or 500 ohm type internal resistance between the terminals of the battery, I hooked them up to 16 volts, and I'll tell you why later on, and let them charge for a couple of hours that way. And what I did find is when I started, they probably were accepting something like 50 or 100 milliamps, and then it went up for a while, and then maybe it went down for a while, but most notably, it didn't really increase beyond that. And the voltage pretty much stayed at 16 volts. And I should point out, the power supply that I used was set up to produce a maximum of 16 volts and a maximum of 1 amp flowing through the battery, because what I didn't want is too much power to go into one of these batteries. And the reason I chose 1 amp was that's about 1/10 of the ampere hours of the battery. So if these batteries are about 10 ampere hours, 1 amp is 1/10 of that. In a perfect world, that would mean a 10-hour charge time. So that's being fairly nice to the battery. We don't want to heat it up, because if we do, well, we could do other damage that way. And even at 1 amp, they do get fairly warm. Anyway, after a couple of hours of that, maybe 3 or 4 hours at the most. I did some testing, and you look at them with the battery tester, and certainly you're getting internal resistances that still are not where you'd hope they'd be, which is probably less than 1/10 of an ohm. And, well, here's where one of the viewers of this channel helped me, and that was Bjorn, who's a longtime supporter. And in the previous battery video, he'd mentioned that for charging AGM batteries, one of the things he found very useful was if the battery was at the point of apparently no return, well, what you could do is take the battery and discharge it and then charge it in the opposite direction and then charge it in the correct direction. And if you did that a few times, you had a good chance of fixing the battery. Well, I thought I'd try that, and I changed the polarity of the charger on these cells and let them charge for a while. The interesting thing is when I did that the first time around, I got like a 1 amp type current, and maybe after half an hour or so that had sort of again degraded to something in the hundreds of milliamps or so. Well, at that point I flipped the terminals again, charged it in the correct direction, and surprise, surprise, it seemed to work. And it was sort of interesting because you could sort of see the voltage across the terminals starting to drop with the current being limited to 1 amp. And after 24 hours of that, and then checking the battery with the battery checker, well, the internal resistance had dropped into the less than 100 milliohms range quite nicely. And the voltage, when nothing was attached, was around 13 and some volts, so it looks like a very good battery. And, of course, there's nothing like an actual test under use, so I took those 2 batteries that I charged that way, and I put them in the UPS that I'd removed them from, and hooked up a 200-watt light bulb, and turned off the power, and sure enough, it behaved beautifully. So, success for 2 batteries, and I did try it on other batteries, and really the key factor was whether the battery tester showed there was any form of resistance between the terminals or not. And if it was just infinite resistance, well, the battery was probably totally dry or sulfated, and certainly beyond the point of any hope of return. Now, that's all good and well, you could say. He's only successfully rejuvenated a few batteries, and I did a few that I didn't show you. But, well, the problem with YouTube is there probably is many videos about rejuvenating batteries as there are YouTubers. Well, at least technical YouTubers anyway, and some of them are quite bizarre. And how do you know that I'm any more correct or reliable than any of the others? Well, I didn't actually dream up this method myself. When I was researching this video, what I did was a fair amount of Googling, and I came across a paper from some professors in Malaysia. And they're from the University Tunku Abdul Rahman. And I'm sorry if I mangled the name of the university, but they did a fair amount of experimentation and tested dozens and dozens and dozens of used UPS batteries. And they seem to be the ones who either came up with the idea or at least validated the idea of charging these things at 16 volts. And it does turn out that if you do charge a somewhat sulfated battery at 16 volts, that's for a 12 volt battery, I should emphasize, well, you can restore it. And they not only did that, they also looked at the plates of the batteries. They did some forensic analysis and found that after that charging period at an overvoltage, well, sure enough, the deterioration on the plates was somewhat reversed, and I believe their conclusion was you could get 70 or 80 or 90 even % of the battery capacity out of the battery after it underwent that sort of a charging process. So there's a fair amount of good engineering behind that, and I'll put a link of the paper. It's really quite interesting to see. So there's a good reason for believing that indeed a 16 volt charge should do it. I think the idea is pretty much the same as some of the chargers out there talk about doing pulse charging. And I think the idea with pulse charging is just like limiting the current. What you're trying to do is keep the battery from getting too hot and destroying itself that way, but using a high enough voltage that you can hopefully start getting past some of that insulating crystallized lead sulfate. Now, the interesting thing is, like most university published papers, they had a lot of references, and quite a few of the references were from third world countries. And I think that sort of is an interesting aspect, because you can sort of imagine in a third world country, labor is relatively cheap. So for a battery like this that might cost 25 to 50 bucks, it's probably worth spending an hour's time to see if you can fix a few of them. In the Western world, in places like Canada, where I am, labor costs are so high that sadly it's probably not worth the risk of spending somebody's $100 an hour time to see if they can rejuvenate $100 worth of batteries. However, if you have a home UPS and the battery is beginning to go dead because the little application from it is saying, hey, I've just tested the battery and you need to replace it, well, it's probably worth trying something like that, because you might save yourself $100, and on top of that, you're also doing something good for the environment, namely you're reducing the amount of lead contamination, because even though these batteries are hopefully all recycled, the whole recycling process is not perfect, and there are of course toxic materials and contaminants that come from that. So it's probably a good thing to do. And it's probably a very economical thing to do in many countries. So, very interesting result. Now, I should point out that the two batteries that I rejuvenated and showed you were from a kilowatt size UPS, and they typically always use two batteries in series for 24 volts. And what I, of course, did was take the battery bundle apart, and it's essentially two of these batteries stacked like that with cables connecting them together in series. Well, what you could probably do with a bundle like that, and I would certainly do the next time, is instead of taking it apart, just attach to the cables in the bundle, and instead of applying 16 volts, apply 32 volts, and try charging them that way, and you would expect both batteries to be pretty much in the identical state of failure or discharge, so that should work pretty well. One thing I should point out for batteries like this is you can occasionally get the situation where one cell is a bit less charged than the others and becomes the limiting factor, and that's also where this type of excessive charging can help, because in the end what it should do is leave all of these cells in as charged as possible a state, essentially an identical state. So it helps for that maybe less common cause of problems as well. Now, I'm also still experimenting with liquid or wet lead acid batteries like you get in cars and lawn tractors, including the fabled method of using Epsom salts to revive them, and that will be in a future video. So look forward to that one. One interesting thing about this video is I use a number of different test instruments, probably more than in almost any other video I've done, and they were all actually provided to me by companies that are supporting this channel. And most importantly, the FNIRSI battery tester was absolutely instrumental in this video, because having an easy way to determine the internal resistance of these batteries really tells you which ones you might have a hope in recharging or rejuvenating and which ones are probably dead in the water. And after you've attempted to rejuvenate them, if the internal resistance hasn't dropped to probably no more than 100 milliohms and preferably less than 50 milliohms, well, you know, the battery is probably not going to be any good. So that instrument was absolutely fantastic to have, and I was very impressed with how easy it was to use, and I really mean it. The other thing that was useful was the Tesmen clamp on AC/DC ammeter, namely the DC part, because sometimes it's nice to verify the current that's going into one of these batteries and not just rely on something like a battery charger or a power supply, for that device is probably less than perfect or less than very accurate estimate of the flowing current. or for that matter, to just see what the current was when I was discharging the batteries. So thank you to Tesmen as well, and also to Kaiwitz, who a long time ago sent me a thermal imager, and once again that turned out to be kind of handy because I was using it to monitor the temperature of these batteries to make sure they weren't overheating and weren't cooking. And not only that, to make sure that there weren't any hot spots from shorts within the battery. And, well, not a bad thing to have if you're doing this sort of thing, not completely critical, but, well, it was handy. So thank you very much to all three of those companies for supporting the channel. It's very much appreciated. And if you're interested in any of their products and not just the ones I've shown, there are links in the description of this video, and there's discounts for some, if not all, of the items. So thanks so much. As always, if you have questions or comments, please put them below. And in particular, if you've tried to rejuvenate batteries of this sort or any type before, tell us what you've done, both whether it worked or not. And telling us what you did that didn't work is really just as important. And I'm sure there'll be a lot to be learned by what people have found as a successful way of doing it or not. And if you decide to try the 16-volt method that I've outlined in this video, well, please tell us how that worked. And as always, if you have suggestions for future videos or questions that you think might make a good video, email me. And as always, I should point out that it's very important and useful for a small channel like this for you to subscribe and, for that matter, like the video. It really does help, and if you do that, I would really appreciate it, and it'll certainly help me make more videos. One of the things it does is encourage companies to support the channel with more and more sophisticated test instruments, so please consider doing that. And, well, as always, thank you so much for watching, and see you next time.